I'm going to talk about solving real-world decision-making problems, so problems that are high value that we've been discussing in the panel that maybe you have with your organization. And let's first start to think about what is these decision-making problems, okay? So we heard several examples. It can be we're using sensors and we want to do better inspection, right? So we're actually using some machine learning to predict whether we have maintenance requirements, and then we want to schedule that maintenance. We need to send out people to do those. We have workforce planning issues. Maybe we want to have routing problems, right? But these are subject to uncertainty, such as, weather, as you were mentioning earlier. Okay, so I would like to start with inviting you to think about a high-value problem in your organization. Okay, it can be procurement, inventory management, routing, fleet management. Okay, something that has to do with decision-making problems. Now, as you think about it, most likely there is something that you don't know perfectly about this problem, right? So you need some sort of prediction. And when we're talking about transportation, logistics, and supply chain, many times we talk about demand as one of the key uncertain components, but it can be something else. It can be costs, it can be, equipment failure, and so forth. Okay? So keep that in your mind, and now I'm going to say a bit about what can the state of the art, where is research right now, and what can it do to solve those high-value problems? And in order to do so, we need to understand what we're really good at today. Okay? So right now, we're really good at a lot of things, thanks to data. Not necessarily, massive amount of data, but high-quality data. We also have high-performing algorithms and massive computing power. Okay, so these are success factors for machine learning that is widely known, why machine learning is so powerful. What I would like to just take a little bit of time is to explain that we're also really good at these very hard optimization problems that I was mentioning. I think Dominique earlier was saying, imagine CN. You need to manage so many assets. There are thousands of locomotives, right? You're running thousands of trains per week. So the sheer scale of these problems are hard. And I'm pretty sure that the problems that you are thinking about right now that are valuable to your organization, they're also large scale. They are hard to solve. Well, luckily, we're really good at solving those problems right now, okay? So we've seen over the past decades, speed-ups just in terms of algorithms, 265,000 times, okay? Now you add the compute power to that, and then you get billions of speed-up, right? So problems that would have taken years to solve a couple of decades ago, now we're solving them in less than a second. So that has a lot of potential. And actually, they're routinely used. Scheduling problems, routing problems are routinely used today. You go and buy an airline ticket, you're going to get prices that you see that are generated by algorithms solving these. Okay, so let's look at that pipeline. What are we good at today and how do we do it? Okay, so most of the times we'll think about, I don't know demand. So I'm going to go out and I'm going to take the best performing machine learning algorithms and I'm going to predict demand, okay? Then I'm going to feed those predictions, so a number for everything that I don't know, to an optimization algorithm that is going to produce a solution. Now, as we have heard from several people, we're not in the game to replace people necessarily. We want to augment them. We want to make their decision-making better, right? So human will look at these and maybe make some adaptations and then implement those solutions, in which case you see what actually happens, right? And so you're going to see what was the demand that I didn't know and so forth. Okay, so we go from forecast to optimization solution to execution, we generate more data, and here we go. Now, the key issue here is that when we're using those predictions, what we're really good at is assuming that those predictions are perfect, okay? Now, this may not be true. And I love this picture, and I stole it from a colleague who posted it on LinkedIn. But let's say that I want to, produce a mattress as the lowest cost, and I do a point prediction on how you're going to sleep. I can do some pretty good job as long as you don't move around, okay? So we're really good at solving problems, but we're not very good at solving problems when they are subject to uncertainty. So if we are really good at making predictions, then we have really good solutions. Now, we want those solutions to be robust, which is not always the case, in particular if there is some degree of uncertainty around those predictions. And to be completely honest, I think all of us who have been working with machine learning algorithms, we know they're never that perfect, right? There is always some degree of uncertainty around those predictions. And here is where what we're doing today in research come into place. So what we want to change perspective, what we want to do is to focus on the outcome. We don't want to implement a solution and then say, oh, we're disappointed. It didn't actually go as the way we wanted it to go, right? So that means that something becomes crucial is uncertainty characterization. I'm not only focusing on getting the best possible predictions, I actually want to characterize also the uncertainty around those predictions. And not only do I want to do that, I also want to optimize and take that uncertainty into account when I'm optimizing. Now, the real issue and why we as researchers still have a job is because that's really hard, okay? Those problems become very hard to solve. So if we go back to this pipeline that I showed earlier, now it looks really similar, but I would like to start with a question. So, either if you're a stakeholder or if you're a developer and you're working on the prediction side, I bet you probably sometime have been in the situation where you're looking at some average error measures and you're saying like, is this good enough? I have like on average a 10% error, or I have on average like 2%, 15%. What's good? What's good enough, right? And then I'm comparing to some baseline model. It's like, okay, so it's a lot better than the baseline, but what's the best I can do, okay? So here, what we're trying to do in research is that we're flipping things, okay? Look at this picture, not the left to the right, but the right to the left, okay? What really matters, and the question you should ask yourself, is not whether my accuracy is good enough, is whether the information my prediction algorithms are producing for the decision-making problem I want to solve, is that information valuable, right? So what we want to do is to train our algorithms not to be very accurate in prediction, but to result in the best possible outcomes for my decision-making problem. So this is how we want to solve the issue of sort of the disappointment when you have implemented a solution that was overly optimistic, right? Think about the mattress. We don't want that mattress, okay? So the end game here is to link better the optimization and the prediction. This is why these are now fused together. These are not siloed. We don't do first prediction and then optimization. We do them together. And we're doing that acknowledging that we have uncertainty, okay? Now, what we want to give the human decision makers who are in the loop, we want to give them solutions that are interpretable. And this is actually even harder when we need to deal about uncertainty. Try asking people about thinking in probabilities. People are usually really bad to have an idea of what is this probability as opposed to the other. So uncertainty is tough also just to digest as a human. So we want good interpretable solutions, and we want to make sure that we're taking into account the risk perception of those humans and the organizations that are in the loop. And all of this is done so that we will actually get, the outcome that we really anticipated when we act in the real world. So this is ongoing research, and it's funded by IVADO, and I'm doing this with co-PIs Eric Delage and Yusiria Adelayasak, and I also have research program funded by CN, which I would like to acknowledge. Thank you.